Every so often in technology, there's a monumental leap. Something that changes everything, from the first transistor all the way to the iPhone. Well, right now, we are smack in the middle of another one of those moments, a complete reinvention of computing as we know it.
Okay, so let's just start with that really powerful statement from NVIDIA's CEO Jensen Huang. A new computing model for the first time in 60 years. I mean, that is a bold, bold claim. So what on earth does that actually mean?
And maybe the more important question is, why now? What happened that made us have to basically throw out the entire rulebook that guided the digital age for our whole lives? Well, the answer is that the engine that powered decades of innovation was starting to sputter out.
That engine was Moore's Law. For half a century, it was the one thing you could absolutely count on, the predictable rhythm of progress. But that era, well, it's over. And we have now officially hit that wall.
And just in case you need a quick refresher, Moore's Law was this simple but incredibly powerful idea that our computer chips would just keep getting exponentially better, year after year. It's the reason the phone in your pocket is literally more powerful than the massive computers that sent astronauts to the moon.
So what stopped this incredible run? It wasn't because we ran out of good ideas or clever engineers. The limit was something way more fundamental. We simply ran into the unyielding, unbreakable laws of physics.
So, to get a little more specific, a key principle called Dennard scaling, which basically kept our chips from overheating as they got smaller, it just stopped working about a decade ago. Performance gains slowed to a crawl. And at the exact same moment, the demand for computation, especially for AI, started to skyrocket exponentially. So we had this massive gap between what we needed and what our computers could actually deliver.
So if you can't make the engine run faster anymore, what do? You have to invent a completely new kind of engine. And this is where the new blueprint comes in. It's called accelerated computing. And it's not just about building a faster chip. It's a complete reinvention of the entire computing stack, from the silicon all the way up to the software.
Now, what's really fascinating here is just how fundamental this shift is. Old-school computing, the kind built around a CPU, does things one by one in a sequence. But accelerated computing, using a GPU, is built for parallel processing, doing thousands or even millions of things all at once. We've shifted from software that had to be coded line by a human, to software that actually learns from massive piles of data.
And the only way you can pull this off is through a concept called co-design. This isn't about making one part better and just hoping the other parts can keep up. No, this is about redesigning the chip, the system, the software, and the final application all at the same time, where each piece is influencing the design of the others. It's this holistic approach that lets you get those huge exponential gains instead of just small incremental ones.
This new computing blueprint has led to something totally new. A new kind of facility, for a new kind of industry. We don't really call them data centers anymore. Not in the traditional sense. We call them AI factories.
And this really shows the difference perfectly. A traditional data center, it's like a warehouse. It stores files, it runs a bunch of different apps, it's a general purpose utility. But an AI factory is a specialized manufacturing plant. It has one job and one job only: to produce intelligence. It doesn't just store data, it actually generates new data in the form of these things we call tokens.
And just like any factory on Earth, its goals are pretty simple. You need to produce a valuable product. In this case, smart tokens. You need to produce them as fast as you possibly can, and you need to do it all cost-effectively. That last part is absolutely crucial for keeping the whole AI revolution spinning forward.
So, what exactly are these tokens that the factories are making? You can think of them as the universal language of artificial intelligence. They are the fundamental unit of information that AIs process, that they understand, and that they generate. The process itself is called tokenization, and it's really the magic trick that lets an AI take any kind of information, words, pictures, complex scientific ideas, and turn it all into numbers. As soon as something is converted into tokens, an AI can start to learn its language, its meaning, and its underlying structure.
And the amazing thing about tokenization is just how versatile it is. I mean, an AI can tokenize way more than just text and images. We're talking 3D structures, chemicals, proteins, even the motion of a robot. This is the reason AI is having such a universal impact across pretty much every industry and scientific field you can think of.
So this is a really crucial point. There's been a profound shift in what AI actually is. In the past, software gave us tools, like a web browser or a spreadsheet, that we the humans had to use.
AI is completely different. AI does the work. It's an agent that can use those tools for you. And this is why AI isn't just another part of the trillion-dollar IT industry. It's a technology that is going to augment and address the $100 trillion global labor economy.
So where does all this new power take us? Well, it takes us to the next great frontier. This new era of accelerated computing isn't just about AI. It's also the key to unlocking one of the absolute grandest challenges in all of science, making quantum computing practical.
The legendary physicist Richard Feynman imagined this over 40 years ago. He realized that because nature is, at its core, quantum, if you ever wanted to truly simulate it, you'd need a computer that operates on those same quantum principles.
But here's the catch, the problem we've been stuck on for decades. The building blocks of quantum computers, these things called qubits, are just incredibly fragile. They are so sensitive to any little bit of environmental noise that they lose their quantum state and produce tons of errors, making them way too unstable for complex calculations.
And this is where our two stories collide beautifully. The solution is to connect the quantum processing unit directly to a GPU supercomputer. The GPU's unbelievable parallel processing power is absolutely essential for doing the real-time error correction that the qubits need to function. Then you have AI running on the GPU that helps orchestrate and calibrate the fragile quantum system. And in the end, the two computers, the QPU and the GPU, they work side by side in this amazing hybrid system, fusing into one single accelerated quantum supercomputing platform.
So this brings us to a final, really thought-provoking question. We have moved from an era of computing that was all about processing information to a new era that is all about generating intelligence. This isn't just a small upgrade, it's a total phase change for technology. And it leaves us to wonder, with this incredible new foundation, what previously unimaginable frontiers are we finally going to unlock next?